Welcome to this failed preparation of hydrazine hydrochloride using butanone azine. In order to make hydrazine-free base, I used 5 times the amount of chemicals used for my hydrazine sulfate preparation. These chemicals are sodium hypochlorite combined with sodium hydroxide, which was this chilled solution, and a solution of urea and gelatin. To avoid overflowing, I combined both these solutions in a 5-liter canister. You can see that bubbles are being formed, and in the solution hydrazine is being formed. I let the canister stand until the solution turned clear, but it decided to overflow anyways, so I was fortunate to have it in the bucket. After it stopped bubbling, the solution was transferred to a large beaker, heating and stirring were turned on, and the solution was heated to 65 degrees Celsius. A lot of carbon dioxide is being removed from the solution, and this pushes our equilibrium to where we want it to be. We next measured out 200 ml of methyl ethyl ketone and added it to the hydrazine solution. The methyl ethyl ketone should react with the hydrazine to form butanone azine, which is not that soluble in water, and this would float on the top. Stirring was continued until I thought that enough butanone azine was produced. After stirring for about half an hour, everything was transferred to a large separatory funnel, and the top layer of butanone azine was separated off. The bottom waste layer was drained into a large canister to be properly disposed of. Butanone azine is slightly yellow, and this confirms that we at least made some butanone azine. The butanone azine was drained into a storage bottle containing molecular sieves for further drying. It might be superior to distill the butanone azine in order to purify it, because in the end we didn't get hydrazine hydrochloride. For the next step, the butanone azine and 80 ml of 37% hydrochloric acid were used, and the amount of hydrochloric acid is a large excess. The butanone azine and hydrochloric acid were simply combined in a large round bottom flask containing a stirfish, and I stirred them for about 2 hours. After the hydrochloric acid had been added to the butanone azine, the solution already turned black, and this is an indicator that whatever I'm going to do next, it's going to fail. After stirring for an hour, a simple distillation was set up, and I decided to distill off most of the liquid, which should be methyl ethyl ketone, water and hydrochloric acid. The solution was somewhat yellow, and this might also be an indicator that the methyl ethyl ketazine, or butanone azine, didn't even react. The solution turned dark black, and this is not good. I decided to get rid of the waste by adding it to a large pan and lighting it on fire. As you can see, this was a pretty bad idea, because a lot of hydrogen chloride vapors were being produced. I quickly grabbed the garden hose and put out the fire. Okay guys, in the end we're left with this black liquid. I'm not going to refine it any further, but it definitely contains hydrazine. I tested it using silver nitrate, and it reduced the silver nitrate to form silver, but just look at all of these impurities. I'm not going to recrystallize or such, I'm just going to discard of it. I will try this again. Maybe it will work if I purify the methyl ethyl ketazine or butanone azine, whatever you want to call it, by distillation first, but this just looks dirty.